Hello everyone. Today, in this presentation, I will be describing capacitors and the uh, usage areas of capacitors. Uh, I've divided my presentation into parts, and first of all, I'll be explaining what is capacitor, and secondly, history of capacitors, and then I'll give some technical information about capacitors, and lastly. I'll be giving you some examples of daily life uh, usage areas in capacitors, how they affect our lives in as a capacitor. What is capacitor? Uh, a capacitor is a device that is used to store charge in electrical circuits, and a capacitor works on the principle that the capacitance of the conductor increases significantly when an insulator material is brought near it. Uh, Hence, a capacitor has two plates separated by a distance having equal and opposite charges. Uh, you can understand what I said and last part uh, by seeing the last uh, last part symbol, and I have a quote from Himanshu Gupta, and be a capacitor, charge yourself for other smoothness, accept variations, be used to tune others, and have larger heart area and lesser distance. Of course, this is not a technical uh, this is not a technical code for capacitors. This is like a metaphor. You can see the metaphors. You can understand better when I explain more about capacitors in next slides. Uh, Now, history of capacitor. The first capacitor was called the Leyden jar. You can see the picture here, which was invented by a Peter van Marschenberg in 1746 in the University of Leiden. Uh, it's in Netherlands. Uh, it was a glass jar uh, wrapped inside and out uh, by a thin metal foil. The outer foil was connected to the ground, uh, and the inside uh, foil was connected to the source of electricity. Uh, if you can imagine in the circuit, uh, like the inside is ground is insulator, it's zero, and the two sides is electricity has this source power. Uh, and Benjamin Franklin in 1752, uh, his famous kite flying experiment he did in 1752, and by doing so he proved that lightning was electricity. And now technical informations. You can see the formulas here, and the Q is the load in the uh, Q is the load in the circuit, and C is the capacitance, and V is the voltage, and unit is farad and measured in farads. Uh, Now capacitance and capacitor, uh, those are different things. Capacitance, capacitor is the device, and uh, capacitance is the has depends some variables like electrostatic constant, area. I mean the plates. I said capacitor has two plates, and uh, the bottom and the right side, the formula A, which means area of those plates, and electrostatic constant, uh, which is E0, and it refers to the insulator, and it depends on the material what you use in between two plates. It can be increased and decreased uh, if you use different materials as an insulator. And distance between plates is affects uh, the capacitance. Uh, so that's basic information for capacitor and capacitance. And now serial series and parallel circuits. Uh, Equivalent capacitors. First of all, before explaining the series and parallels, capacitance. Now, what is series, and what is parallel? As you can see in the picture, they if they uh, came after instantaneously, like on the same line, which means they are series to each other. But if in the circuit, if it separates into two different lines, you can understand they are parallel. And of course, for their equivalent, uh, if you find their equivalent capacitance, they have different formulas for series and parallel. You can see the series capacitance formulas. C equivalent equals 1 divided by 1 1 divided by C1 plus 1 divided by C2, and it goes on like 1 divided by Cn. Uh, and parallel capacitance formula C equivalent equals C1 plus C2 plus C3, and it goes on like this until Cn. And now usage areas, the application of capacitors. So basically, uh, they don't supply power constantly, but they have a short time they supply power, which means they are not supplier, but uh, if uh, but as you know, they have storing electrical energy. So uh, as that short time they release that energy, they look like they work like a supplier voltage source. So, and also vehicles audio system they have in it. So sensing device and and lightning capacitors is like everywhere. So these are the references. That was my end of my presentation. I hope you enjoyed, and if you have any questions, I will be trying to answer them. That's all.